Welcome. Today, we're moving beyond the typical conversations about CI/CD pipelines to discuss a more profound operational model, GitOps. Let's be clear from the outset. GitOps isn't just another tool or a fancy name for automation. It is a fundamental paradigm for managing both infrastructure and applications, where Git becomes the definitive, single source of truth for the desired state of your entire system. The core idea is simple yet powerful. Everything that can be described declaratively, from your Kubernetes deployments and service meshes to your cloud infrastructure itself, is defined in a Git repository. This repository isn't just for source code. It becomes the holistic, version-controlled blueprint of your operational environment. The principles are straightforward. The system must be declarative, versioned and immutable, pulled automatically, and continuously reconciled. This shift transforms operations from a series of imperative commands into a declarative convergence process, which we'll explore next.
The engine at the heart of any GitOps implementation is the reconciliation loop. This is where the theory becomes a powerful, practical reality. Instead of a traditional CI pipeline pushing changes into your cluster, GitOps employs a pull-based model. An automated agent, an operator like Argo CD or Flux, resides within your target environment. This agent's sole purpose is to relentlessly compare the desired state, as defined in your Git repository, with the actual state of the live system. Let's break down this loop. First, the operator continuously pulls the Git repository for any changes to the target branch. When it detects a new commit, it fetches the updated declarative manifests. Second, it observes the live state of the cluster's resources. Third, it performs a diff. It asks the critical question, does the actual state match the desired state? If there is a discrepancy, a concept we call drift, the reconciliation process begins. The operator calculates the necessary actions, whether it's creating new deployments, updating config maps, or deleting services, and applies them to the cluster. This loop runs perpetually, ensuring the system is self-healing. If an engineer makes a manual out-of-band change using kubectl, the operator will detect this drift on its next cycle and revert it, enforcing the Git repository as the only source of truth. This pull model is also a significant security enhancement. The cluster's credentials never leave the cluster boundary. The operator pulls changes, eliminating the need for external systems to have administrative access.